DACLs on the kernel component so that somebody else can't go in and start talking directly to your kernel code, because that opens up a lot of attack surface that you don't want to be exposing. Right, so when you've once you've componentized your code, or broken it down into different components that are manageable, then you can also start to look at which of these components are actually possible to run with lower privileges, for example. Can I take, for example, this file format parser and break it off, spawn it off into a different process, because I've got easy input and output from it. I've got an input of a file or file handle or a file path to it, and I've got an output of a parsed data structure. That's pretty easy for me to partition off and compartmentalize so that that code, which might be doing some hairy stuff, parsers always are difficult. Can I run that in a lower integrity level process with a restricted token and all of these mitigations that we've talked about, or security features as I call them? If you're going this route and sandboxing stuff, check out the blog series by David LeBlanc from 2007 called Practical Windows Sandboxing. That's kind of the it documents how they kind of went about developing their own sandboxing techniques for Office, and it's kind of the start of, or rather Adobe has built on that work with the new Adobe Reader 10.0. So have a look at that, because it does bring up some important points that you need to be aware of when sandboxing low privileged processes. Also, when you're looking at these components, make sure that these interfaces, this should actually be a part of your threat modeling if you haven't already done it, make sure that they're simple and clear, that they're non-ambiguous, that you understand the inputs and outputs and how that relates to other components in the system. And apply the principle of least privileges. If these components don't actually need access to system resources, then that code doesn't actually have to be running as a standard user. And if these components are too complex or require too many privileges, you should perhaps look at refactoring them and changing them and making the interfaces cleaner and simpler to make it easier for you to understand the implications and do threat modeling and stuff like that. In a perfect world, basically only the UI layer of your application would need to run with a full privilege set of the user, and perhaps not even that. That's not going to happen for most application developers, but you should at least strive to look at componentalizing and compartmentalizing those components within your application to make sure that you're using all of these features that you can be using in Windows to make it harder to attack your application. And basically, a lot of these features can be bypassed. I talked about /GS being easy to bypass if you're using an older version, for example, if you're using Visual Studio 2003 still. And what I want to convey to you is that doesn't matter to you. If you can use enough of these mitigation techniques and security features, then they will overlap to such a degree that it will make it significantly harder for somebody to exploit a vulnerability in your software, that you will have won so much by just doing these simple steps. There are no silver bullets to application security, but if we can just raise the bar enough that an attacker would either go after some other company or if we can raise the bar to such a degree that it's making the attacker invest a lot of time, effort, and money into making the exploit for a particular vulnerability, we will have protected our customers that much more. So we need to build securities in security as overlapping layers. So even if one of these layers isn't perfect, there will be another one underneath and another one. And hopefully either an attacker won't get through, or all of them, or it will be at least very costly for them to do so. Look at each component in isolation. Make sure that it's responsible for upholding the security of itself by verifying its inputs and making sure it produces safe output as well. Assume nothing but validate everything. So it's better to have several components within your application actually verifying the same data several times over than just verifying, hoping you've verified everything when you've read it from disk, for example, and then just trusting the data from there on in the application. So make sure that each component that you isolated, and when you're doing the threat modeling, make sure that it doesn't assume anything of its input, that it validates everything before it uses it. So to summarize a bit, build security in your applications by piling on everything that you can of this that we talked about. All the exploit mitigations that you can enable, please enable them on all operating system levels that support them. All of the toolchain features that you can use, please make sure that they are enabled. And it can be hard because sometimes you have to depend on third-party libraries that, for example, aren't DEP aware or don't support ASLR. But if you've got a lot of problems with that and you can't address it by demanding from your third-party software vendor to fix it, look at, for example, Emmet or something else as a workaround. Architecture in components. Make sure that your application isn't a monolithic application, but actually does make sense when it's broken down into separate pieces that might even be developed by different teams internally. And review them in isolation to make sure that they actually do what they're supposed to do, that they can stand on their own when confronted with arbitrary inputs and stuff like that. And once you've done that, try to partition your application and put components that don't need privileges into a separate sandbox process or something like that. And use the other Windows features to raise the bar for the attacker. So if you're sandboxing something off into another process, don't just put a restricted token on it and hope for the best. Learn from Microsoft. Check out the Practical Windows Sandboxing article series and pile on all of these features to make sure that the sandbox is tight. Look at, for example, the Google Chrome sandbox that they use. They've done exactly that. They've tried to use all of these Windows technologies to sandbox off all of the rendering and HTML processing in the browser into a separate process. And also look at the Microsoft SDL. There's a document, and I'm not sure if I'm getting the name correct, but I think it's referred to as a simplified SDL. And you shouldn't be confused by the name. It's basically the SDL process documents that have been stripped from everything Microsoft specific and specifically made to be able to, for you as an application development team, to adopt basically straight off, because all the Microsoft specific parts have been edited out. So look at that and adopt the parts at least that make sense to you. Any questions? Anything? Yeah?
So you just went over in detail a lot of security measures that are available. I mean, the obvious question, if you don't mind me drawing for that, is why are we still seeing so many problems within Windows? Are people not using it, or are the issues that we're seeing?
Yeah, so just to repeat the question for the camera. If we've got all of these lovely exploitation mitigation features and everything in Windows in the toolchain, why are we still seeing so many attacks against Windows applications? Well, if you look at Microsoft and their applications and Windows in general, which is a large code base, they've done pretty well recently because they are using all of these features. So I would say it wouldn't be too far of a leap to say that third-party developers aren't, and that's probably why they are having, or are getting targeted, rather, because they're an easier target for attackers. So if I was to attack a system today, I wouldn't be attacking IE, I wouldn't be attacking Outlook, I would be attacking the Java Sun, the Oracle Java JRE, I'd be attacking the Adobe Reader 9.3 that isn't fully patched yet. I'd be attacking those kind of things, or the Flash plugin in the browser or something like that. And that's what we're seeing today as well in the wild, is that the attackers are going for the easy stuff, which is, until now, those large third-party vendors that have a large installed base and haven't adopted all of these mitigation techniques yet. Any more questions or comments or anything? Corrections, have I got anything wrong? I probably have, but read the white paper and send me feedback on that instead. Okay, if there's nothing else, then thank you for listening to me, all 5 of you. These are my contact details. I'll be around the rest of the week if you want to come talk to me. I'd love to speak to you. Otherwise, I'm done. Thank you.